Aloha and welcome to our video on the sun. In this video we'll explain the structure of the sun, we'll describe some of the physical features on the surface of the sun, and we'll explain how the sun produces energy. Okay, so let's take a look at the structure of the sun. In the center we have the core, and this is where the bulk of the nuclear reactions are happening. From here we have our radiation zone, and this is where we have the outward pressure of the explosion of all of these nuclear reactions occurring. Now, outside of the radiation zone, we get to the convective zone. And in the convective zone, you can see we have these little convective current circles here that are going. And that's going to play an important role on what we see on the surface of the sun. Now, using the term surface is really kind of interesting. If you look, we have a photosphere here, and this is going to be a boundary between the convective layer and the chromosphere here. This photosphere is what we would call the surface of the sun, but remember that the sun is just a big ball of gas, so it really doesn't have a true surface. We just have boundaries to where we're seeing these things happening. Beyond the chromosphere, we get to the corona here, and you can see that. And if we look around, we'll see some other parts of the sun as well. We have the granulation, which we'll see on the surface, and there's pictures in the lessons, but we'll show you those. We have sunspots, and we'll talk about those a little bit more. And then we also have these things called prominences. So we'll talk about those a little bit later on in the video. So if we were to look at the sun through a telescope, this is what we would see as long as we have a filter on it. Remember, if you look at a sun through the telescope, so much light's going to come through, you'll probably burn your retina. Not a good thing. But we can look through it with an appropriate filter placed on it. When we look at the sun, and this is what Galileo did, he noticed that there were blemishes on the sun. And if the sun is the most perfect thing, then according to Aristotle, it should have been a perfect sphere. And when we look at it, it is spherical in shape, but it did have those blemishes. Those blemishes were called sunspots. And if we look in the picture on this side here, we can see that we have a sunspot here, a rather large one. It's going to have an umbra, a darker part here, and then a penumbra around it. So just like our eclipses and our shadows, we talked about the true dark part is the umbra, and then kind of a lighter part being that penumbra here. We also can have some pores that we'll see there, and most sunspots are going to come in pairs, so we'll see two of them together. And then we talked about the granules, and you can see the granules down here, how it's kind of the surface of the sun is kind of granulated, and we see that because of the convective nature of the gases below, so they're kind of bubbling up and such like that nature. Now, these convective areas are going to create magnetic fields per se, so we'll have a north and a south magnetic field, and what we notice is connecting these two on the surface is where we'll see these solar arches or these prominences. And sometimes when we have this magnetic field, it'll switch around, it'll turn off, or the prominence will be so large that it'll break away like we see here, and we can have what we call a solar flare. And that's just a massive ejection of all this energy from the sun coming out at one time. And this can mess with some communications or satellites throughout the solar system as this energy rushes out away from the sun. Now here we can see another solar flare. You can see the prominence is split and it's going to break off here. One of the interesting things about these solar radiations, these massive outgassings, is when it gets into the upper levels of our atmosphere, it'll cause what we call the northern or southern lights. And you can see a really nice picture of it here. And this is when the sun's energy hits our ionosphere, the top of our atmosphere, and it causes it to radiate or glow. And that's what the northern lights would be. So we'll talk about the formation of a star in another video later on. But inside of the sun in the core is where we're seeing this nuclear fusion. And what happens in this nuclear fusion is we're going to have this hydrogen nuclei. And this hydrogen nuclei are going to come together and they're going to form helium. And it's going to be helium-3. So what we have is a hydrogen here, one proton, another hydrogen here. And now when they collide, notice we have two protons and one neutron, and that's going to form helium-3. Now, this is the first part. Notice it's releasing radiation in the form of gamma rays, but it'll release it across the entire spectrum. And then what happens is we will have two helium-3 nuclei collide. So as these two helium-3 nuclei collide, it'll release more energy, and we form this normal helium-4 ion here. This is the nuclei part here. So this is what we're looking for, two protons, two electrons, a helium-4 nuclei. But we also release out these extra hydrogens. And if we notice, this is part of our process here. So this is how it'll repeat the cycle until we use up all of the extra hydrogen. And that's when we'll talk about the death of a star later on in another video. Okay, as always, the lessons will go into a little more detail. Good luck on your quizzes, and we'll see you in the next lesson.